the Newsvendor model service level measures. So if we calculated a quantity, for example, when we maximize the profit, we calculated the order quantity, we can now evaluate what kind of service this quantity will deliver. And there are two measures we can look at. One is expected fill rate, which is the percentage of satisfied demand. And another is in-stock probability, that is the probability of being in stock throughout the whole season, right, in which we are selling the product. So expected fill rate, as we said, is percentage of satisfied demand, can be calculated in this case as expected sales divided by expected demand, right? And expected sales was 3060.16, expected demand 3192. So we have almost 96% of demand satisfied. And this is not surprising, right? Because we're actually ordering more than the average demand, and we're satisfying most of the demand. This is an expected fill rate. Of course, the actual fill rate might be 100% or might be 90% or 80% with different probabilities. Another measure that we can calculate is the in-stock probability. The in-stock probability is the probability of not having a stockout, right? So we have a stockout probability, which is 1 minus in-stock probability. If you recall, we will be in stock when demand is Q or less. So that is equal to the cumulative distribution function for Q. And because we actually set this value, we set Q such that this value is equal to critical ratio 80%, our in-stock probability in this example is also 80%. In general, we can calculate the in-stock probability using this function, right? Norm dist, the cumulative distribution function, assuming quantity Q, mean and standard deviation of demand. And this is just saying use the cumulative distribution function, not the density, right? If Q is determined by profit maximization, our in-stock probability will be the same as critical ratio. So actually, we didn't have to calculate anything. We already knew the in-stock probability is 80%, no calculation necessary. And of course, stockout probability in that case is 20%. When we compare these two service level measures, you will see like both of them are some kind of percentage, and you will see that most often expected fill rate will be higher than in-stock probability. In some extreme cases, they could be equal or very close to each other, but it's never that you never have in-stock probability higher than fill rate. You can see the relationship on this chart. As we change the order quantity, the fill rate is increasing faster than in-stock probability. And we can actually consider simple examples. So, for example, if I had an order quantity of 100 and I can have a demand 80, 90, 100, 110, or 120 with equal probabilities. This is the table that considers all the cases, right? So if you consider, right, the actual fill rate, not expected, if demand is 80, remember quantity that we have is 100, then we will sell 80, right? We will have enough and we'll have some leftover, so we will fill all the demand. And we will be in stock also, right? If demand is 90, we'll sell 90 because we have 100 units, again, the 1. If demand is 100, we match exactly the quantity, right? We have a fill rate 1 and in stock status 1. But if the demand is higher than quantity 100, right, then, right, there's this quantity. Let's actually maybe highlight it, right? If demand is 110, then of course we can only sell what we have, and we have lost sales. And now fill rate is only 100 over 110 of demand. So it's roughly 91%. And then if demand is 120, again, the fill rate is decreasing. But notice the in-stock status kind of changes from 1 all the way to 0. And it doesn't matter if we're short of 1 unit or multiple units. So you can see because of this relationship, right? Because when we satisfy all demand, both measures are 1, right? Fill rate and in stock. But when we satisfy part of the demand, this measure just drops by a small percentage, whereas this measure drops to 0. If you consider expected fill rate, which is the average of all possible actual fill rates, and expected in stock value or probability of being in stock, which is the average of all those actual in stock statuses, then you see that in stock probability will always be less or equal. In stock probability will always be less than or equal the expected fill rate, right? So what we used here actually is that fill rate before demand occurs, we can only have expectation, and in stock before demand occurs, we can only have probability of being in stock. Whereas after the demand occurs, we will actually have the actual value of fill rate, right, which will be 100% or 90 or 80 or something else. And in stock probability, we'll have either 1 or 0, right? The actual value will be 1 or 0, never fractional, because after the demand occurs, we know we were in stock or we were not. And finally, if we have service levels, we can actually ask the question of what if we want to set the order quantity to achieve a desired service level. So there are two cases here. We can either have a desired in-stock probability, and in that case, right, for example, find Q such that in-stock probability is 99%. Well, it's just actually very similar to maximizing profit, except that now instead of setting FQ to critical ratio, we set FQ equal in-stock probability that we desire. And of course, right, we can do calculation exactly the same, taking the inverse of the cumulative distribution function for this probability rather than for critical ratio for the normal distribution, cumulative normal distribution function with a given mean and standard deviation. In our example, it will be 5,940. And this is, of course, you can see that this number makes sense. The average demand is a little bit over 3,000. If we want to be 99% of times in stock, we have to order much more than the average demand. Of course, it all depends on the standard deviation. Now, if you want to have a satisfy expected fill rate, for example, if we want to find quantity such that expected fill rate this time is 99%, there is no easy formula. There's no easy formula, unfortunately, so we can't just do a calculation like this. The best way is to use Excel and adjust the quantity until the fill rate that is calculated using our fill rate formula presented earlier achieves a desired value. So I will just change Q until fill rate becomes 99% expected fill rate, right? You can do this manually, and actually this is the recommended way, or you can use a goal-seek facility in Excel, right? So for 99% expected fill rate would be, for 99% expected fill rate, the order quantity Q has to be set to around 5,005. So here is an example Excel spreadsheet that can do calculations for us, and we can try to solve for all three cases. So here you have the inputs, price, cost, salvage value, calculation of underage and overage cost, and then expected demand and standard deviation as other inputs. And of course, here we calculate critical ratio using underage and overage cost, right? And then profit maximizing quantity will be a norm in function for the critical ratio mean and standard deviation, right? And I actually use roundup just to get an integer value because quantity that we order has to be integer, an integer number, right? And here there is an evaluation of the chosen quantity, right? With expected shortage or expected lost sales, expected sales, leftover profit, maximum profit, mismatch cost, and also as a percentage. And here is the expected fill rate and in-stock probability, right? So what if I wanted to get an in-stock probability 99%? Well, actually in my spreadsheet, I can just overwrite the critical ratio. Instead of having here a critical ratio, I could just say this is in-stock probability, right? And just change it to 0.99, and then it would give me the value 5,940, and of course this evaluates it. And notice, by the way, the mismatch cost is now much higher than before, than 33,000 or so, and the expected profit has dropped, right? From the maximum profit, it's now 55,000 away from the maximum profit. So This is not a profit maximizing quantity, but it gives us a better service level. What if let me undo this. What if I want 99% fill rate? Notice I already have 95.87 fill rate, percent fill rate with this quantity. So this is of course too low. I want 99% in this case. So I can try and increase. Let me try quantity 4,500. Well, it's 97 now, right? This is the value. So if I try maybe 5,000, well, it's almost there to a 98.99%, right? If I try 5,100, it will be 99.17. So it's close to 5,000, and you can actually, by playing with the number, discover that some value around 5,005 gives you almost exactly 99%. Again, is that exactly 99%? If we see more digits, you'll see that it's not actually exactly 99%, but it's extremely close to that number. So that's the way that we can find order quantity that will give us a desired desired fill rate.